Okay, so now we begin alcohol nomenclature. It's important for you to know that alcohol has a higher priority. It's more important than just alkanes. It's more important than halides, right? So I'm going to show you an example of that later in the next example, but for now you just need to know that it's actually more important when you're naming alcohols. So it's actually kind of easy to name alcohols, especially when they're just simple alkanes attached to it. So again, we're just going to count how many carbons we have. We have 1, 2, and 3. This does not count. This is actually just an oxygen bond, so it's just three carbons. If it's 3 carbons, then it's going to be propane, right? Except you don't have the E right here, right? When you have an alcohol, which is just an OH group, you'd say PROPAN, and then instead of saying the E, you say OL. So it's propanol. So that is propanol. It's a common name, right? However, if you want the IUPAC name, you're gonna have to be a little bit more fancy. So you're gonna say propan, right? We have like the same thing right here. But now you're going to say 1-all. So this 1 just kind of like merges its way between the propan and the all. But why is there a 1? Well, whenever you're naming these kind of molecules, you want to start, since it's more important, since alcohol is more important, you want to start near it. So we say that this is the first carbon, this is the second carbon, and this is the third carbon. We do not say that this is 1, 2, and 3, because then you're putting the third one, you're putting the most important child on the third number, and that's not good. If anything, we always want to put our child on the first number, if possible. If we have the child on the closest number to 0, which is like 1, right? 1 is pretty close to 0, then that's good, because it's more important. It's the favorite child. Okay. So because alcohol is more important, we're going to start counting near it, right? Especially when they're just simple carbons. No double bonds, no triple bonds, right? So we say propan, we put the location of where the alcohol is. In this case, it's on the first carbon. So propan, and then we have alcohol on the first carbon. Alright, for this one, we have a substituent. Hopefully you notice that this is a 6-carbon parent, right? 6 carbons, and we have a methyl group, which is just a little line right there, hanging off of the, let's see, 1, 2, 3, 4, off the 4th carbon. Okay, so since it's 6 carbons right there, because it's 6, that means we know it's going to be a hexane, right? It's like hexagon, hexane has 6 sides. Oh, and we have an alcohol, right? So instead of having hexane, we will have hex, AN, and what? All. Right. So it's hexanol, because it has an alcohol. But then we have a substituent. Now normally, if the alcohol were not there, you would say 1, 2, and 3, because that's better than having 1, 2, 3, and 4, right? But the alcohol is more important than just a methyl or an ethyl or propyl, right? So alcohol is going to have more precedence, is what you would see in a book. It just means importance over the methyl group. So instead of counting from left to right, we're going to count from right to left, because we always want the alcohol to be on the lower number. Okay, so we have whenever you do this, kind of like separate your children first. So just say what you have. You have a 4-methyl, and you have a 1 alcohol, or yeah, well, you can say that. You have a 1 alcohol. Okay, so now we're gonna put this together. We're gonna say this is a 4-methyl 1, and instead of saying 1 alcohol, you say hexanol. Now you're probably wondering, hey, shouldn't the alcohol go first because, alphabetically A comes before M? Well, yeah, it should, but the alcohol actually comes in for the suffix. See, a suffix is something that you put in behind a word. A prefix is something that goes before a word. So in this case, alcohol would be the suffix because it goes after the parent name, hexane. So a suffix is something that you put behind a word. And suffixes are for the most important groups. So the most important group was alcohol, therefore it's going to be the suffix. Therefore it's going to be the OL after the end. So you're going to have 4-methyl-1-hexanol. The 1 just shows you where the alcohol was. The 4-methyl is just a child. It's not the important child. It's not like the favorite one. The favorite one would be the alcohol, right? On the exam, he might, show a different word. He might do this. He might do 4-methyl. 4-methyl hexane 1-all. So he just kind of shifted this right here between the hexane and the all. And I recommend that you practice both styles. That's what we're going to be doing in this video. We're going to be practicing both styles of how to name alcohols, basic and non-basic. So this is going to be 4-methylhexane 1-all. This can also be 4-methyl-1-hexanol. It just depends on your style, but I recommend studying both. Alright, this molecule, it is attached to a 5-carbon parent. So this alcohol is attached to a 5-carbon parent. And since alcohol is more important, since we want to name it on the lowest number, we're going to number it from here. 1, 2, 3, 4, and 5. Doing this, numbering from right to left, will give the alcohol on the first carbon, not on the 5th carbon. That must mean that we have a what? That we have a methyl group on the 4th carbon. So we can say that we have a 4-methyl 1, no, not hexanol, pentane, and then what? What do we have? An alcohol, so we say OL, pentanol. Now, another way you can name it is that you can say this. 4-methyl pentane, and then 1-all. So it could be 4-methyl-1-pentanol. It can also be 4-methylpentane 1-all. You're just shifting the 1 between here. And that's perfectly fine. You might see that on an exam. Also, going back to our previous example, since this is what we called a propanol, it can also be called propan 1-all, right? Because alcohol's on the first carbon, you could say propan 1-all. And let's see here. There's a 1, 2, and 3. So it's 3 is going to be, actually, let's do a different one. Let's do this one. Okay. So 3 and 4, that's going to be butane. 4 carbons means it's butane, but it has an alcohol, so it's going to be a butanol. Butanol. And let's see which carbon we're going to be on. I like to have my alcohol on the lowest carbon, so that's 1, 2. If I numbered from right to left, it would be 1, 2, 3, 4. So I'd rather have a 2 than a 4, right? So we can name this as butan 2-all. Butan 2-all. So it's the name, location, and the child name. So parent name, butane, location, 2, child name, alcohol. So butan 2-all. Alright, so now it's another predicament that we have. We added a halide. A halide is just a fancy word to say a halogen. It's a chlorine, bromine, iodine, or fluorine group. And, you're probably wondering which is more important. Actually, the alcohol is going to have more importance than a halide, because halides and simple alkanes, see, if we were to ignore this, this would have the same importance as that, or as a methyl group. But since we have an alcohol, it's actually going to be more important than a chlorine, or a fluorine, or a bromine, or iodine. It's going to be more important. And since it's more important, we're going to be naming it first. Alright? So first we're going to name our number of carbons. So that's not a carbon, that's not a carbon. Those are actually bonds from the chlorine and the oxygen. What our carbons are this: 1, 2, and 3. Since it's 3, you're going to have methyl, ethyl, propyl. So it's actually a propane. Right? So we know that this is a propane. And since I want to name my alcohol first, I'm going to put 1, 2, and 3. This gives me the alcohol on the lowest number possible. I don't want it on the third one. I don't mind chlorine being on the third one. I'm not really favoriting chlorine. I'm actually favorable towards alcohol. So I want alcohol to be on the lowest number. Okay. So we have to name out what we have. We have a 3-chloro, right? We have a 3-chloro. And we can bring this together. So we can say 3 dash, don't forget your dash, chloro dash, and let's see, what location is this on? It's on the number 1, so we can say 1 propan all. Similarly, you can say 3 chloro propan, and then what? 1 all. So 3-chloropropanol, or you could say 3-chloro-1-propanol. Just depends on however you want to write it. In this video we're going to be doing both styles so you can get a hang of it, so it becomes more naturally to you. So 3-chloro-1-propanol, you can also move this one between this and merge these together. So if you merge them together you get 3-chloropropan, but the one shifted so it's 1 all. Okay? Okay, so this looks like a mess, but you just have to count. So 1, 2, 3, 4, and 5, so it's a pentane. But we have an alcohol, so it becomes pentanol. And notice that I have some children on the, on the 4th carbon. So we have 2 methyls. We have 2 methyls, that becomes a dimethyl, so you have a 4-dimethyl. Of course, you don't use the di when you're alphabetizing. You actually use the M, right? So you use the M instead of counting. So di or tri, tetra, that doesn't count. What counts is the child name. So it'd be like M or B for butyl, right? So we have a 4-dimethyl, and we have a not an oxygen, but we have an alcohol on the 2nd carbon. So if we put this together, we have a 4. Well, actually, since there are 2 methyls on the same carbon, we're going to put a comma. 4-4. That means there are 2 things on the 4th carbon. I don't know what, but there are 2 things. Dimethyl. That tells me, oh, there are 2 things on the carbon, and they're both methyl groups, because they're di, right? So 4,4-dimethyl, don't forget your comma, dash 2-pentanol. And if you were to look at it, if you were to look at this name, you would have 4,4-dimethyl-2-pentanol. So there are 2 things on the 4th carbon, and it turns out that those 2 things are both methyl groups. And then we have an alcohol on the 2nd carbon, and a pentanol means that there are 5 carbons altogether, so that's a pentanol, right? And similarly, you can say 4,4-dimethyl pentan 2 all. Now we're going to do something a little different. We're going to kind of jump into the waterfall. We're going to go into the lake, right? So we're going to step up the difficulty a little bit. We're going to write out the molecule from the name. It's not that bad, actually. First of all, when you look at this, don't focus on anything else yet. Don't focus on this part. Don't do that. Instead, focus on this part. That's the parent. Well, we have pentane, so I know we're going to have 5. We're going to have 5 carbons, first of all. Right, so 1, 2, 3, 4, and 5. And we have an alcohol somewhere, but I don't know where the alcohol is. So I'm going to look at my location. Turns out that the alcohol is going to be on the first one. So it's arbitrary. You can put it on the right hand, you can put it on the left hand side. I'm going to put it on the left hand side. We put a OH. Don't put OH like that. Don't do that, because then you would be saying that hydrogen has 2 bonds attached to it. That's not true. So we put HO. Okay, so we're done with that. So we're going to kind of like cross that out. Now we move on to the phenyl. Well, what's a phenyl? A phenyl is actually just kind of like a weird structure. Right? It's like a weird structure. And it's going to be directly attached to our little parent chain. So that's a phenyl. But notice that it's not a phenol, so it doesn't have an alcohol attached to it. It's just a phenyl. So it's going to be on the first carbon as well. It's going to be on the first carbon as well. So, yeah, this is going to be 1, 2, 3, 4. Oh, sorry. This, right? Because that's a carbon, this is the carbon, that's a carbon, this one. So 1, 2, 3, 4, 5. Okay? So let's see here. Alright. So we're going to have a phenyl right there. It takes practice to get your hexagons that perfect. Not really. So yeah, I mean, you know how I kind of messed up where I said, you know, this is like an alcohol, I'm going to put my alcohol right here on this carbon, but then you would have 4 other carbons left. Well, you know, I'm really sorry, but like, that's 2, 3, 4, 5. Those would be the 5 carbons. This bond right here does not count. That's actually the oxygen bond attached to the first carbon. So I'm really sorry for that. I misdrew the molecule. So that would be 1, 2, 3, 4, and 5. This bond right here is not a carbon bond, that's actually an oxygen bond. Alright, sorry about that. So 1, 2, 3, 4, 5. Okay, so we got the phenyl down. That's good. It's on the first carbon as well. Now we have a 3-methyl. So we're going to put our methyl right here. Usually when it's going downwards, you want to put the methyl going downwards. You don't want to have it like that. Looks ugly. So you have a methyl. And yeah, we actually drew out the structure. Not bad, right? We just went from the right to the left. So we had a pentanol. That means we have 5 carbons. We have an alcohol. I don't know where the alcohol is going to be at. Oh, well, it's right there on the first one. So I'm going to put the alcohol on the first carbon. Right? It's going to be on the first carbon. And then we're going to have a phenyl, which is just like a benzene ring, except it's attached to the parent molecule on the first carbon as well. So this carbon has an alcohol group and it has a phenyl group. Then we're going to put a methyl, which is just a little line, on the third carbon. That's all we're doing. Another way that this name could be presented on the exam, it could be what? It can be 3-methyl 1 phenyl pentane 1 all. So yeah, it could be 3-methyl 1-phenyl pentane 1 all, or it could be 3-methyl 1-phenyl 1-pentanol. So either way, you now know how to actually draw out molecules from the name, not just from the picture. So now we go to our weird kind of famous alcohols that we can do, right? So these are like the famous ones that you should know. This is 1, 2, 3, that's propane. That's a propanol. That's propanol. You can also call it propyl alcohol, or you can just call it propan 1 all, right? On the other one, it's 1, 2, 3, 4 That's 4 of them, so it's a butane, but has an alcohol, so we call it butanol. You can also call it butyl alcohol, or you can say butan 1-ol. So butan 1-ol, butanol, butyl alcohol. You can call it different names. It's all nicknames for that. It's cool. Now this one kind of looks like a T, right? So it's gonna have tert. Let's see, 1, 2, 3, 4. So tert. If it's 4, then it's butane, but we have tert butyl. So that becomes a tert butyl. Tert butyl. And it's tert because this carbon has 1, 2, 3 carbons attached to it, so it's a tertiary carbon. That must mean that this alcohol is a tertiary alcohol. So tert butyl alcohol. Okay. And now we have what? Now we have some weird looking thing. You know, it looks like 2, 3, 4, right? But actually it is 4. It's a butyl. But notice where the alcohol is. Imagine that this molecule is attached to some parent, right? Hey, we're attached to like the second carbon. And, well, let me rephrase that. Imagine that this whole molecule is actually attached to a parent carbon because we're acting as like a child, right? So this would be a child. And what you need to know is that this is going to be called a sec butyl alcohol. So that's a sec butyl alcohol, right? Because we have the alcohol on the second carbon, this whole molecule is going to be a child. It's going to be attached to the parent chain. So that's a sec butyl alcohol. This one on the left is going to be what? It has 1, 2, 3, 4, and 5. And it looks like a hand too. So if it's 5, then usually it's going to be a neopentyl. But we have an alcohol, so you could say it's going to be neopentyl alcohol. And this one has 1, 2, 3, 4. Since it has 4, it's going to be butane, but it has a Y shape. And if it has a Y shape, then it's usually going to be iso. So you can say iso butyl alcohol. So now this is kind of, you know, it's kind of different from the other problems that we've been doing, right? Whenever you have 2 alcohols attached to the same molecule, it's going to be called a diol. So this is a diol. You can also call it a glycol, but normally we call it diols. So how do you name this? Well, again, just start normally. Just start with your carbon right here, 1, 2. That's 2 carbons. That means that it's an ethane. So, you know, we're gonna have ethane right there, but we have an alcohol. So you can say that this is a. It doesn't matter where you count. You can count 1, 2. You can also count 1, 2. No matter what, your alcohol is going to be on the first one. Your alcohol is going to be on the second one. It doesn't matter for this one. So we're going to number from right to left. That's just me, right? So we are going to say that this is a what? We have a 1, 2. That means there are, you know, there's an alcohol on the first one. There's an alcohol on the second one. We can say 1, 2. And what else? You don't say diol, you say ethane diol. Notice how the E was retained. We didn't put ethane, we put ethane diol. So whenever you have diols, you want to put the E, you want to put like you just keep this, right? So instead of saying ethane diol, we put the E. We keep it and put diol. Right. So what this name tells me that there's an alcohol on the first one and the second carbon. There is an ethane, so there's 2 carbons altogether, and we have 2 alcohols. That's a diol. on the exam, it could be shown as ethane -1, 2 diol, right? And again, we just move this part right here. That's all we're doing. So it's ethane 1,2 diol. Or it can even be called by its common name. So ethylene glycol. Ethylene glycol. So glycol, just remember that it's the same thing as having two alcohols, and that's the same as saying diol. So ethylene, ethyl, well, you know, ethyl means two carbons. So if you were to be given this on the exam, you could draw it out. Ethylene glycol. Ethylene, two carbons, glycol, two alcohols, right? It's the same case for this molecule. We have 1, 2, 3. So it's 3, that means it's going to be propane, but it has two alcohols, so it's going to be with the diol. We have 1, that's not a 1, that's 1, 2, 3. So we have an alcohol on the first carbon and an alcohol on the third carbon. So we say 1, 3. Do we say diol? No, we don't say diol. We say propane diol. Alright? So 1, 3 dash propane. We just kept the whole name, propane, and put a diol as a suffix. Suffix is something that goes after a word. In this case, the suffix would be the diol, right? So we have a 1, 3 propane diol. We can also say propane 1, 3 dash diol, right? And you know, you can also say, you know, propanyl, if that's how you spell it, propanyl glycol. Really bad at spelling. So it could be propanyl glycol or propane 1, 3 diol, 1, 3 propane diol. So again, you just move this right here, right there, and you get this boy. Actually, sorry, this is not propanyl. This is going to be propylene. Sorry, propylene glycol. Yeah, so not propanyl, it's going to be propylene. Like ethylene, except it's propylene. So it's like, it rhymes with gasoline, right? So propylene, ethylene, methylene, butylene, right? Hexylene. Okay, sorry. For our last example, we have this molecule that has two alcohols. If it has two alcohols, we instinctively know it's going to be a diol. Now we have to count our carbons. So we have 1 carbon, 2 carbons, 3 carbons. So if it's 3 carbons, it's going to be what? It's going to be a propane. But since we have 2 alcohols, it's going to be propanediol. We just have to count our alcohols now. So we can go from left to right. You want to start over here. So 1, 2, and 3. This is good because I have an alcohol on the first carbon and an alcohol on the second carbon. If I number from left to right, we have 1, 2, and 3. And I don't like having an alcohol on the third one. I'd rather have 1 and 2 instead of 2 and 3, right? 2 and 3 add up to 5, 1 and 2 add up to 3. 3 is going to be the lowest number. 3 is lower than 5. Therefore, 3 is going to be better than 5. So we're going to number it from right to left. So 1, 2, and 3. We have 1, 2. Do we say diol? No, we don't say diol. We say propane diol. And again, we can also say propane 1, 2 diol, right? Or you can use a common name, propylene diol, or not diol, glycol, right? So diol is the same thing as saying glycol. So it's propylene glycol, propane 1,2 diol, or 1,2 propane diol. Again, I really hope that this video helped you out with your alcohol nomenclature. You learned that alcohols are actually more important than halides or simple alkanes. You learned that 2 alcohols is going to have a diol, or it could be called a glycol. You learned that the location can be on the front, or the location can actually be between the parent name and the suffix. Suffix is something that goes after a word. In this case, diol would be the suffix. I hope you found this video helpful. Make sure that you study and you're going to do amazing on your next exam. Thank you.